Hi there, this is Carl Irwin with another Blender tutorial. This is part 5 in a series on OpenGL rendering inside of the Viewport using environment mapping, a new capability that's part of Blender 2.78, where we can take environment maps and now we can map them to objects within the scene in such a way that we can influence the lighting of those objects by using textures rather than using physical lights inside of the scene. This is all a very subjective kind of art form. This is not really true physically based rendering. We are taking a little bit of artistic license and trying to sort out a way to use these textures in order to generate a more photorealistic kind of imagery using these textures. I just want to quickly review where we've been and where we've gone. We had the first episode of this series. We discussed the conversion of equirectangular environment maps, which are widely available, into the Blender box mat format, which is a common format used in gaming, and that is the type of format that is essential for mapping onto objects within the scene. The environment map, however, on the outside can be an equirectangular image. We can use equirectangular images for the world texture. However, when it comes to mapping the objects themselves, we have to use a box map format. So we went over a method for converting those images into box maps. We also talked about developing a diffuse box map, which can be used for soft lighting, such as what you see in this object here. In the second episode, we talked about how to composite these materials together in the material slots and also inside of the node editor in sort of a procedural way, such that we can merely change our textures and it will automatically update for objects in our scene. We put together a couple of node groups, one big node group in particular that looked like this, where we were using our diffuse texture to map out our shadows, and then using an OpenGL light that would come from the approximate light source inside of our scene to mask out further shadows on our objects. And we came up with these two node groups, so one for diffuse lighting and one for a shadow mask. The next episode we discussed reflections, and we came up with this node group here that generated a somewhat realistic looking reflection, where we have a Fresnel effect where there is a deeper reflection on the outside edges than there is on the inside. And we also developed inside of this node group a control so that we could change the influence of these different parts of the reflection, the interior and the Fresnel effect. We also developed a Fresnel texture in order to pull this off. And this is a very, very important node group because it's going to be useful in our topic today, which is going to be refraction. Just to quickly refresh your memory, we generated this node group that could control our smoothness and our our roughness of our reflection. So we could change that. So we could have completely reflective material, or we could have a more roughened material with that Fresnel fall off. In addition to that, we created a node group for color so that we could change the color influence of our reflections. And that's this node group right here. It just has a saturation and then a color curve in it. In addition to that, we talked about in the next episode specularity, such that we could generate sort of a subsurface car paint kind of feature. Looks like there's a clear coat finish over top of this undercoat of blue. And we also discussed the idea of using textures to generate bump maps, and we came up with this one over here, which looks like a metallic fleck. And if we put that through both our color and our specularity, it looks like we have kind of a fleck paint, like what you would see on automotive paint. We also discussed the possibility of having bump maps applied to the objects in such a way that it affects the OpenGL light shadow and also the diffuse texture. So we also found a way to map that and generate new materials from that technique. Today we're going to look at refraction, and we're going to develop a node group that accomplishes something like this. So it looks, at least I hope it looks, like we are refracting the imagery in the background as if this was a crystal clear sort of material, so that we can look through it and we see this kind of refraction effect. There's a little bit of chromatic aberration going on in there. We'll talk about perhaps how to accomplish that. Now, this is, I think, passable. However, I admit this is really just the best we can do. It's a fairly bogus kind of stand-in for true refraction. Unfortunately, I have not been able to find a way using either material slots or the node capabilities to map an environment texture, a box map, in such a way that we can rotate it or flip it within the 360-degree environment. What I did find was that we could use the geometry and, output and the vector mapping node to kind of come close, and we get kind of this twisted image. So this is a completely bogus refraction. This is not true to life at all. However, I think it's passable enough, and especially if we add on to this a couple of other realism effects, we can make it look usable. So if this looks good to you, good enough, then keep watching. If you're looking at this and saying, no, I'll just, render internally or use the Cycles version of the current Viewport PBR, then that's fine. But if you don't have a computer capable of that and you think this is passable, then keep watching here and we'll discuss how this is done. So before we take a look at that node, I would prefer probably not to just jump right in there, because it does look a little intimidating. It'd be a little easier to build this, and you can actually choose to use a few of the steps that I'm going to discuss and go no further, or you can use all of the steps that we're going to discuss and make it look a little bit better perhaps. But there's kind of a simple way to do this, and then there's a more complex kind of method. So what we'll do is we'll start with the simple one, and then we'll add to that and make it a little bit more interesting. So with that, what we need to do is I would hope that you've seen the other episodes of the series, and you watched the episode, I think it was the third one, where we talked about reflection, and we generated this map here, this reflection light map. What we're going to do is we're going to duplicate it, and then we're going to make it its own user, and we're going to rename it. I'm going to call this refraction 2 because I've already done it once over here, so we'll do another version of it. And I'm going to take my output from this node group and put it into the output over here. So this is just the reflection one. You can see we have our reflection on there. This is going to be our base for what we're going to accomplish here. Let's tab into this node and see what we have going on. If you recall, we had this mask here that was masking a Fresnel effect of the diffuse and the reflective material to come up with our final composite. We want to reset a couple of these controls. We want this to be absolute black on the left, and we want this to be absolute white to start out with. Okay. And then what we want to do is on our mix is we're actually going to flip these. We're going to take the diffuse texture and we're going to move it to the other slot, and we're going to reverse the mapping here. So now our diffuse is on the outside of the Fresnel, and then the reflective material is on the inside of the Fresnel. The next thing that we want to do is I'm going to take this curves adjustment. I'm going to get rid of it. And we don't need the shadow mask node either. I'm going to get rid of that. I'm just going to drop the diffuse directly into the bottom slot. So we have kind of this situation right here. So the diffuse is going in here, and then the reflective material is going up here. We need to make quite a bit of room here, so I'm going to move my nodes around to give us a little bit of space. We're not going to change this Fresnel map up here in any way. We might change the color ramp a little bit later on down the road. What we're going to do is we're going to use the diffuse as the Fresnel effect for the refraction. When you have refraction, you get a Fresnel effect much like you do with reflection on hard surfaces. However, it is kind of the opposite. Instead of getting an increased detail and reflectivity on the outside edge, what you get in a refraction is you get kind of a neutral color on the outside edge. All of the detail of the scene seems to disappear. So what we're going to do is we're going to use our diffuse material to accomplish that. And then likewise on the interior, on the normals facing you, you would see the refracted image from the other side of the object coming through fairly clearly. So that's why we reversed it. Now what we need to do is we need to map our textures in such a way so it does not look like we're looking at a reflection from our point of view, but rather that we're looking at what's on the other side of the object coming through it. So this is the best way I found to do it. We're going to add here a geometry node, and then we're going to add a vector map. Okay, and we're going to take the normal from the geometry node and drop it into the vector input. And then we're going to take the output of the vector and we're going to drop it into both the diffuse and the reflection. Now you'll notice nothing has changed because the map is exactly as it would be coming from our texture input. Everything on here is zeroed out. What we're going to do though is we're going to change a few of these settings. We're going to go to rotate, and we're going to change each one of these to 90 degrees. So we'll do 90 on X, 90 on Y, and 90 on Z. And you're going to see that we're actually looking at parts of the image from the other side. So over here we can actually see part of this building coming in. And then over here we can see part of the end of this building. So we're looking through it, but we kind of see this dual image where they meet together, and it's as if we go this way, it's as if the image is twisting. So you kind of see this effect going on here. Now, this is not really what would happen. Instead, what you might see is a reversal of an image depending on the formation of the object, or you might see an enlargement of it. You would not see this twisting, but this was the best way I could get to look through to the other side of the image. And what we're doing is we're actually looking on the very edge of the reflection has been stretched out into this area. So, I don't know. If you think this works okay, then like I said, keep watching. If not, then I hate to disappoint, but we're not really going to be able to pull off a true refraction. But I think this is passable. I think that, if you had an object in the scene that wasn't the full focus, you could probably get away with this. So we're going to do that. Now the next thing we're going to do is we're going to go to the Z, and we're going to just kick up the Z value probably to 1.6 like that. We'll kind of enlarge the image a little bit, which is something that would happen. And now not only has this affected our reflection, not only has this affected our reflection, but it's also affecting the diffuse. So the diffuse texture is doing very much the same thing. Now what we want to do with our diffuse texture is we want to get some of the color out of it. It should be more of a neutral gray. So I'm going to add in here a color, hue, and saturation. And I'm going to take the saturation down quite a bit, probably to 0.6. So it's more of a neutral gray. There's still a little bit of the color retained in there. Okay, and then we can go up to our map here, and we can our Fresnel map, and we can try to fix this and get it a little bit cleaner. We want this Fresnel effect to be kind of right out on the outskirts, so we're going to take the black and we're going to slide it in towards the white. The white represents the Fresnel, and the black represents the refraction. And if we move that out towards the edge, you can see that we get pretty close there to what a Fresnel effect would look like. So as you're looking at the more oblique areas, the more acute angle, we get this very dull looking kind of refraction, and then in the center we get the far more detailed sort of refraction. So you can play around with this a level and get it to a point where you think it looks satisfactory. Again, there's a lot of artistic license in this. I think that looks pretty good. Now, the truth of the matter is that you could be done right here. This is a pretty good effect. Now, I did play around with a couple of possibilities that we're going to investigate right here to try to add a little bit more, I don't know, some convincing detail in there to help us sell the effect a little bit. Now, before I do that, I just want to show you one more thing here. Much like what we did with the reflective material where we could change the roughness, we can actually make this a more of an opaque, translucent, frosty kind of material, so like a frosted glass. And the way that we do that is we just go up here to our Fresnel color ramp and we go to the black color, and if we increase that on the white, we will add in our diffuse texture, and in fact if we go all the way up to white, we'll end up with this kind of frosty looking refractive material. So it's like a frosty marble kind of look to it. So this is kind of an idea sort of approaching subsurface scattering techniques, and we may look at that a little bit later. Like I said in the last tutorial, I did a fairly extensive tutorial on creating subsurface scattering materials in OpenGL, and that tutorial still stands for all of what we're talking about here. You can still do all the same techniques, but this is kind of a fairly quick and easy one-stop shop to get a translucent kind of, I don't know, frosty glass or waxy sort of material. You might be able to composite this in with another solid material in order to generate, I don't know, some sort of a subsurface scattering kind of effect. Okay, maybe even applying a Fresnel effect to that so that just parts of the image use this as the map for diffuse. So we'll look at that a little bit later, but I just wanted to show that to you, that using the color ramp you can kind of use the same technique as we did with reflection, although we can change the opaqueness of our refraction. Let's take this all the way back down to black again. What we're going to do is we're going to try to create a little bit of a chromatic aberration in our refraction. So what we need to do is give ourselves a little bit more space here. We need to duplicate our refractive material. In fact, I'll slide this down here. I'll duplicate it, slide it up, and we're going to need to create another instance of the mapping. So we'll duplicate that, and we're going to put that into this normal here. And then I'm going to bring my normal out from the geometry node into the vector. And what we're going to do is we're just going to change, in fact, let's get this on the output so we can see what we're doing. I'm going to change the size of this in a moment, but first I want to add a bit of a color adjustment to it. So we're going to add to this a color, hue, and saturation. Oops, try that again. Color, hue, and saturation. And we're going to take the saturation down quite a bit, 0.5. And then we're going to add to that a color curve. So I'll bring the color curve out here. On the curve, we're going to go to the red channel. We're going to bump the reds way up high, and then we're going to go to the RGB curve for all of them, and then we're going to create quite a bit of a contrast here. I might bring this down quite a bit. We want a high contrast kind of curve where we're just getting a little bit of that detail to stick out red. Okay, so something that looks a little bit like that. And then what we're going to do is we're going to duplicate this in a moment. First I want to increase my size here. So we'll go up one click from where we were up to 1.7, so I increase the Z. And then we'll take this whole group here and we'll select all three of these things. And we'll duplicate them, slide them up, and we'll bring our vector normal output from our geometry node, and we'll drop that into the vector on the top. And I'm going to take this size and we're going to take it down a click. So we have the main image is 1.6 scale, the red is 1.7, this is 1.5, and we're going to change the curve over here. We're going to go to the red channel and get rid of that point, and we're going to add one for the blue. So we'll increase the blue. If I put this on the output, you can see what that looks like. So it's kind of the inverse, but it's going to be a slightly different size. So that's the blue, and this is the red, and you see that they're slightly different in size. Very minor change. What we're going to do then is we're going to take these two outputs, we're going to add another mix node, and on this mix node we're going to mix them together half and half, so 0.5 for each. Then we're going to add another mix node, and we're going to bring our reflective material, our original one, out into the top slot, and then we're going to bring our composite red and blue into the bottom slot. And we'll put this out over here to the output. And what we want to do is we're going to change the mode to add. And we'll bump this all the way up to 1. So what we're doing is we're adding in some blues and some reds that are a little bit offset on our image. And it adds just kind of that feeling of a chromatic aberration. It kind of muddies up the image a little bit and gives us a little bit of that chromatic aberration kind of effect, which would be seen inside of a translucent material. We can take this output then and drop it into the top. So now our composite reflection material is coming into the top of our mix, and then we'll drop all of that into the output. And then this would be our new material. So all of that, slide this over, take our Fresnel down just a little bit. So all of that goes together to give us this final output. Now, the very last step here, which I neglected to include in the demo at the beginning of this tutorial, is that we need to have a reflection on the outside of this. Now, there's probably a couple ways that you could do that. You could use the reflection tool that we already have created and then composite that on top of it. But probably the better way to handle it is to go back in here again to our node setup, and we're going to try to duplicate our Fresnel effect here so that we can have our refraction appear as though it would on kind of that car paint surface. So we're going to need the Fresnel effect so that the the reflection is a little bit more prominent on the outside edges than it is in the center. So the way we'll handle that is we're going to bring in very quickly our reflection group that we've already created. So we'll grab our reflection GL lights, and we're going to tab into this. Actually, one thing I want to do is I want to make this its own instance so that we're not playing around with the settings of the original one. We'll tab into this, and we want to set this, in fact, let me get the output. We want to set this such that we are only seeing the outer reflective material and not the diffuse. So what we're going to do is we're going to make sure our settings here are the way they ought to be. Complete black on the left, complete white on the right, and then on the diffuse texture we're just going to delete these two spots here, these the diffuse input, and we're just going to put a black color on the top, and then we're going to change our ramp here to tighten it up a little bit so the reflection is just kind of on the outside edges. And then we're going to add to that a hue and saturation. It's going to be very subtle reflection. We're going to set the saturation down to 0.5. And then we're going to add to that a color curve. We're going to increase the contrast quite a bit, so we'll put kind of a stark contrast curve on this. So we're just getting a little bit of that reflection, on the outside edges, a bit of that Fresnel there. We'll tab out of that node, and then we're going to add here another mix node. And we'll set it to add. We're going to put our output from our refraction on the top. We're going to put the output from the reflection, this special reflection node on the bottom. And then we'll put the output through here. And now we just need to set our level to an appropriate level, so that you can kind of see this reflection happening on the outside edges here. We'll pump it all the way up to the top and see what we get. So you can see we're getting a little bit of that reflective outside specularity. And that may be sufficient enough, but it is important that you do have a little bit of reflection because it is a hard surface. Perhaps another possible way to deal with this is to add in another group, which would be the specularity group. And rather than having the this special reflection come in, we can just put the specularity into the bottom. And we would have to go in, make it its own user again, tab into that. We would have to tighten down that curve as well. But essentially, if you recall, the specularity node is accomplishing the same thing. We just have a lot of whites in there right now. So it's a possibility, you know, one way or the other, it doesn't really matter. But you want to end up with the specular highlights from the reflection, and you want it to be, you want it to follow this kind of Fresnel fall-off effect on the outside edge over that neutral gray. You wouldn't want really any reflection on the middle, because if there's light being refracted through the material, you wouldn't see a reflection on the outside. It's kind of like with a TV screen. You see reflection on the outside of the screen when it's off. You don't see reflection when it's on. You could have a glare from a very powerful light that overpowers the TV, such as from a window or something like that, but you wouldn't really see any reflection otherwise. You would only see the specularity whenever the light is very low on the television image or if the screen is off. So that's the idea. Anyway, just wanted to make sure we got that last step in there. It wasn't showing on the original example here, so make sure that we cover all of our bases. Anyway, that's refraction. So that's my idea for refraction. Now, one thing you need to be aware of is that this will not refract objects in the scene through it. You're looking only at the environment map. So much like the reflection, it will only reflect whatever is in the environment map. Now, the good news is that once you have your scene put together, you can generate a environment map just for this object. All you do is you select the object, and then you go to the texture slot, rather the material. You generate a new material that's shadeless. You add a texture into it, and you make an environment map texture, and you go through that process like I talked about in episode 1, where you can save an environment map. You can render out an environment map, and that will have all of the objects in the scene so long as that image or that object stays stationary, and so do the objects around it. It will generate a map for those other things inside the scene, and you can move the camera around and you will see those objects refracting through it. So at this moment, there is not a way to generate an OpenGL live updating animated environment map. Now, there is a script. There's been a number of scripts actually through the last few years that have been created for the game engine that can generate environment maps in such a way. It will save to a kind of a blank image, blank PNG image updating per frame. We can't do that from the viewport, unfortunately, and I don't know why that is. If there's anybody out there that's had any kind of experience with that Python code, that script, I would strongly encourage you or invite you to look into it. If you know anything about coding, look into the possibility of bringing that code into the viewport capability. I mean, it seems to me if this is a GLSL environment, much like the game engine, that we ought to be able to do more of the things that we can get away with in the game engine here. But I'm not sure. Maybe not. I don't know. I know that the game engine is a frame renderer. But in a way, isn't this a frame renderer? You know, I don't know. These are questions I don't have the answers to. But I just want to pose that out there for anybody that might be in the know, that there is some capability, although it isn't available in the viewport. It'd be nice if it was. That would take us a lot further. So anyway, that's my idea for today. Coming up in subsequent episodes, we're going to look hopefully a little bit at subsurface scattering. And then we're also going to kind of depart from this material making, and we're going to look at the possibility of bringing in models that already have textures, bringing them into this environment and setting them up so that those materials are using the environment map and the diffuse to be lit by the scene. So that's something else we're going to be looking at later on. Using models that you may download or may have made already, and then making them compatible with this environment and able to utilize the environment maps. So anyway, I hope you enjoyed this and got a lot out of it. Hope you have a use for it. I guess there's one more thing I should mention before we depart here. This color node that I made here for the reflection, you potentially can change the color of your glass, and I just want to mention this real quick. All you have to do is drop that same kind of color adjustment on there and it will change it. So this is a little crazy here, but we could lighten this up a little bit, bring up these curves, and you could colorize your glass and even the frosted glass by using a curve adjustment or by using this same node group. So I just wanted to make sure that you were aware of that. You really would treat this refraction node group in the same way as you would treat the reflection one, and there is one difference in that this material would not have shadows. It would not cast shadows because it's always going to have light bouncing inside of it. So there's no need to have the shadow group on it. Anyway, that's all I've got for you. So I wish you the best of luck with this and happy blending.